Angle 9. John?
They're alternate.
Alternate, very good. But remember, we can't just say alternate. Hey, alternate interior. Guys, notice I'm writing out the whole thing. Interior, it matters, and then angles. Let's go. 4 and 9. Guys, did anyone figure out what the relationship between 1 and 9 was? Alexis? Yeah. Corresponding.
Wait, for corresponding is
Angles. To abbreviate, don't do it. Okay. Number 1 and number 12. Cody. A, alternate exterior. Oh gosh. Alternate exterior. Oh my gosh, Mr. Yurko. Spell. Exterior. And then angles. Okay, what did we get for 6 and 11? 6 and 11. Marcus? Yeah, corresponding. Our transversals changed there. Do you guys see that? This should have been your transversal now. So 6 and 11 are in the same spot. So corresponding. Angles. Did anyone get the last one? 7 and 4. Hayden? Very good. Consecutive. Interior. Angles. Did anyone get all of them right? You got 4 of the 5? Good. Okay. Do we understand what we did wrong if we missed one? Excellent. Guys, you can also, instead of consecutive interior, what else could we have put? There's another way to say it. For 4 and 7. Nobody remembers from yesterday? If you say same side interior, that's fine as well. Same side or consecutive interior are both fine. Alexis? Why is 10 corresponding? So go along that green line. Do you see both the intersection points? The 6 is top right, and so is the 11. It's top right, so those are corresponding. Do you see that? Top right, top right. What's up, Cody?
Could you have used like the other line?
What do you mean?
Like you know, like there's this line. Remember you said like you just have to use the line that crosses the two.
Correct. But 6 is formed at this point, and 11 is formed at this point. The only line that goes through those 2 points is that line. You couldn't use the line over on the lines. Alexis? No, the one that's alternate exterior with 6 would be 14. Do you see the difference? Because 14's on the exterior, 11's on the interior. John?
I forgot to draw the box.
Yeah. My box would be right here. You see that? So 9, 10, 7, 8, 11, they're all interior angles. Does that make more sense, Alexis, or no? Be honest.
Oh, I get it now.
You see it now?
Yeah.
Okay. Top right, top right. If it was alternate exterior, 6 would match up with 14. Okay? Good questions. Any other questions on this guy? Yeah.
Is that okay?
No, because you're using 2 transversals there. I just drew it right there. Okay? Now, it depends on what transversal you're using. So, like, let's say they were comparing, wasn't one of them comparing 4 and 9? Our box would be different, okay? If they're comparing 4 and 9, our transversal becomes this guy, and our box becomes this. Do you guys see the difference? It all depends on what your transversal is. So now 4 and 9 are alternate interior angles. Cody?
Why is the box not like this?
Because there's 2 transversals in there. Do you see how there's 2 lines that pass through?
Yeah.
So those of you that drew your box like this, there's 2 lines that are cutting through here. You don't know which one's your transversal, okay? So just draw one box at a time. You could draw it around these 2, and then you could draw it around these as well, okay? Because there's 2 transversals going through there. Yeah, Ronnie.
How do you know when to like change your transversal?
It all depends on the angles that you're comparing. So like when they compared 4 and 9, right? The only line that includes those two angles is this line right here. Do you see that?
Yeah.
It's the line that like touches both of the angles. So like when we changed it, when Alexis was asking about 6 and 11, or no, excuse me, yeah, 6 and 11. Do you see how this line touches 6 and 11? That becomes my transversal now. Okay? These are really good questions. Any other questions? All right, peeps. If last lesson was good for you, this one's going to be even easier, okay? Use parallel lines and transversals. So all the lines that we're looking at today, we're going to have parallel lines and they're going to be cut by a transversal. When this happens, it's a very specific scenario, but when this happens, a bunch of congruence occurs, okay? We get 4 theorems right off the bat. Corresponding angles become congruent. Alternate interior angles become congruent. Alternate exterior angles become congruent. And your consecutive interior angles are supplementary. You have 1 postulate and 3 theorems because of it. The only one that's a postulate is the corresponding angles postulate. The rest of them are theorems. All right, guys, I want to make something like crystal clear. This is a very specific scenario. What has to happen in order for these to be true? They're cut by a transversal, but what specifically is cut by a transversal? 2 parallel lines. If they're not parallel, can we apply any of these theorems or postulates? No, okay? They have to be parallel, okay? They have to be parallel. Okay, so we're gonna find the measure of each angle. Guys, there's some things when it prints, sometimes the things get jumbled around. So please, please, please follow what I'm gonna do. Cross out the 130 that's right here. Cross out the 7 and cross out the 6. The 6 is gonna go beneath the 5. The 130 will go right here across from the 5. And the 7 will go up there. Cross out the 6, yeah. And then put the 6 underneath the 5. Do you see where I put it? Okay, now guys, one thing that I need you to understand. Do you see how these 2 lines appear to be parallel? Yeah, they appear to be parallel. We're never going to assume that they're parallel. How we know that they're parallel is because they have this mark right here. If you ever have an arrowhead in the middle of your line, and there's another line with an arrowhead in the middle, that means that those 2 are parallel, okay? So do you remember how we used to mark stuff with like congruent symbols? It's very similar to a congruent symbol, but that means that they're parallel, not that they're congruent. Do you guys all understand that?
Yeah.
Okay? The arrowhead at the end means nothing. It just means that that line is going on forever. But when it appears in the middle of the line, that means that it's parallel. Gucci? Okay, so these 2 lines are parallel, and they're cut by a transversal. Highlight the transversal. It's this guy right here. We are only given one angle, which is 130, but we're going to be able to figure out every single angle just with that angle, okay? So if this angle is 130, let's use our first postulate. What would be the corresponding angle to the 130 degrees? Benji? Nope. German? 3. So the 130 and the 3, based on our postulate, corresponding angles are congruent. So the 3 has to be how many degrees? 130. So let's fill that into our chart. Angle 3 was 130. Okay. 130 is also alternate exterior with what angle? John?
I think 2.
2, very good. And remember, alternate exterior is going to be congruent, so its measure must also be 130. Now, look at angle 3. If angle 3 is 130, how could we use angle 3 to figure out angle 2 also must be 130? They're congruent, but why?
Because they make a straight line.
No, Anja, they're vertical, okay? So you're going to notice that these two are vertical. That means what other angle down here must also be 130? Mario? Excellent, 5 because it's vertical. So we found out 2, 3, and 5 were all 130. Fill in your chart. So 2 is also 130 and 5 is also 130 degrees. Okay. Are there any ideas on how we could figure out any of the other angles? John?
You could subtract 130 from 180.
Why?
Because it's a line.
Which one? Okay, you're absolutely right. But which angle are you looking at right now?
Okay, so angle 5, you can subtract 130 to 180. I don't know what I'm saying.
You're right.
180
You
from
subtract
130 and then you get
130
angle
from 180, and you could get angle 7 because 5 and 7 are what? What's their relationship?
Supplementary.
Supplementary because they are they are adjacent.
Next to each other.
They're a linear pair. A linear pair because together they form a line, do they not? So 5 and 7 are a linear pair. Together they must add up to 180. So we do 180 minus 130. What's the measure of angle 7, Mario? 50 degrees. Okay, hold on. If 7 is 50 degrees, Mario says 6 has to be 50 as well. Do we agree with Mario?
Yes.
Why would 6 be the same measure as 7? Hayden? No, they're not a linear pair. No. Zach? They're vertical, okay? They're vertical. You said that they were a linear pair. Oh, I didn't hear that second part. Okay, they are vertical, so it's 50 degrees. Okay, how are we going to figure out 1 and 4? But don't use that they're a linear pair. John?
7 and 1 are both X. Wait, I gotta find out what that.
Ooh, 7 and 1 definitely have a relationship. What are they?
I forgot the word.
Sophia, help them out. Very good. They're corresponding. So this also must be 50 degrees. Guys, 4 and 7 also have a relationship. What is their relationship? Benji? Very good. And alternate interior are also congruent. So all of these are either 50 or 130. 4 is going to be 50. And then 1 is going to be 50. So every single angle was either 130 or 50, right?
No.
Except for 8. What is the measure of 8? 90. So 8 must be 90 degrees. Okay. Do you see the other right angle mark up here? I didn't have to give you this. How could you determine that if 8 is 90 degrees, why would this one have to be 90 as well? Why would this guy have to be 90 as well? John?
Because both those lines are parallel.
They're parallel. And what about this angle relationship means that it also must be 90? Macy? Very good. They're corresponding. Do you guys see that? So this one, if this one's 90, the corresponding angle must also be 90 because these lines are parallel. Do you see it? A little bit? Okay, let's move on. Find the missing values. They gave us one angle. We had to figure out those 4. They gave us one angle. we have to figure out those 4. Let's start with finding x. What is the relationship between the 110 and the x? Let's start with the relationship. John?
They're both a linear pair.
No.
That's not.
Remember, a linear pair would be if x was over here, right? Because they have to be adjacent to be a linear pair. These guys are not next to each other. They don't share a side. Cody?
Consecutive interior.
Very good. They're consecutive interior. Now, guys, consecutive interior is the one that's not congruent. Do you guys remember from the first slide, what's the relationship between consecutive interior? John?
Consecutive is like they're next to each other.
Yes. But what do we know about them when they're cut by parallel lines? Mario? They're supplementary, which means what, Hayden? They add up to 180. So we can write 180 equals 110 plus x. And we can solve for x, right? We just subtract 110 from both sides. We get x equals 70 degrees. Take that 70 and use it to try to figure out what this angle is. Identify their relationship and then set up an equation. What's their relationship, Cody?
Corresponding.
They're corresponding, and corresponding angles must be supplementary or congruent? Congruent. So we're going to set 2y equal to 70. And then do what? Divide by 2. We get y equals 35 degrees. But remember, this angle was 70. Do you agree? How do I compare 2y and 2z? What's their relationship? Hayden? Very good. They're corresponding or consecutive interior. No, not corresponding. Shoot, you tricked me. They are consecutive interior. And we know consecutive interior angles are congruent or supplementary. Supplementary, okay? 70 plus 2z must equal 180. We subtract 70 from both sides. We're going to get 2z equals 110. Divide by 2. Z is going to be equal to 55. Cody?
So you can't use 110 and have them be alternate exteriors?
With which one?
Never mind.
Now, this original 110 is also, it has what relationship with this angle down here? They're corresponding, right? And corresponding angles must be congruent. It was this 110. If you take 55 and you multiply it by 2, do we get 110 down here? Do you see how those are congruent? Light bulbs should be going off. Are they going off? A little bit? A little bit?
Yeah.
Not really?
No,
Alexis.
Wait, 70 plus 27?
What?
Oh, 2.
That's 2z. That's a z. Sorry. Any other questions so far? We've got like 2 more things and then we're done. Okay? All right. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. What is the measure of angle 1 and how do you know? When it asks you how do you know, from here on out, I want a theorem. Okay? So, if the measure of angle 2 is 40 degrees, who can tell me why and what the value is of the measure of angle 1? Sophia?
Would you do 180 minus 40?
180 minus 40. And what would you get there?
You would get 40. Oh no, sorry, 140.
140. Okay? So you're saying the measure of angle 1 is 140 degrees? You're saying angle 1 is 140?
Yeah, no, that's wrong.
So the one set of angles that this happens are for consecutive interior or same side interior. So what you just found was this angle. You said this angle is now 140. But angle 1 is over there. Sophia?
Is it
Very good. It's 40 degrees by the alternate interior angles theorem, okay? Alternate interior angles theorem. Now, nobody mentioned this, but we can only apply this theorem based on something that's given in the diagram. Can anyone tell me what was given in the diagram that allows us to use this theorem? Carson?
The parallel lines.
Yes. Very good. Circle those guys. That is the most important part of the entire problem. If these two lines were not parallel, could we say that angle 2 and 1 were the same? No. Okay? They have to be parallel in order for us to apply this. Okay? And do you guys agree this purple, this violet line, that's our transversal now? Okay? So the two parallel lines are not your transversal, the one that cuts them. What's up, Ronnie?
Wait, what would you do, like, 180 minus, like, 40?
Yep, so just what Sophia found. She found these two, right, which are same side of the transversal and interior, same side interior. Those are supplementary. But whenever you're going over the transversal, if it's alternate, it should be congruent. So this 40 is going to be congruent to the 40. Also, if you did that and you got this angle, does that angle look like it's 140 degrees? Why not? It's acute, so it needs to be less than what? 90. So that doesn't even really make sense. Do you guys agree with that? That should be a check for you. Like, does it make sense in this problem? Okay? Any other questions on this one? Those are good questions. Okay. People, the last one, we're going to write our own proof. Yeah, baby. Okay. All right, so what is the only thing that we're given? That's the parallel symbol. Write it down if you don't know it. That symbol means parallel. It's also given to us in the diagram that P is parallel to Q. We need to prove that angle 1 is congruent to angle 2. What is their relationship right now? Angle 1 and angle 2. Alternate interior. Do we know that alternate interiors must be congruent? We're going to use this proof without using that theorem. So let's get started, okay? So we're going to start with our given, which was P is parallel to Q. Divide it, and let's get going. So this is number 1, number 2, okay? So we know that these two are parallel. What can we do as our first statement? Try using angle 3. What do we know about angle 3? Angle 3 is corresponding to angle 1. And since these guys are parallel, what do we know is true about angle 1 and angle 3? They're congruent. So we're going to start with angle 1 needs to be congruent to angle 3. And our reason, which theorem did we just apply? Or postulate? The corresponding angles, that's the only one that's a postulate, okay? Corresponding angles postulate. Now, in step number 3, remember, we're trying to prove that angle 1 and angle 2 are congruent. Do you guys agree? But the only statement we have involves angle 1 and angle 3. Can you think of something else we can do to get angle 2 involved somehow? John?
Angle 3 and angle 2 are vertical lines.
Good.
Vertical.
They're vertical. What do we know about vertical angles, guys?
They're the same.
They're the same. So we can say angle 3 is congruent to angle 2. And that was using what definition or theorem? John said what word?
Vertical.
Vertical angles theorem. Okay. Now our last step is to somehow say angle 1 and angle 2 are congruent. Does anyone think they know why we're able to say angle 1 and angle 2 are congruent? Cody?
You want like a property?
Yes, I want a property. It would be transitive. Property of congruence or equality? Very good. So angle 1 is congruent to angle 2. And you would put for number 4, transitive. What else could you put there? Substitution. Property of congruence. Let's look at it. If 1 is congruent to 3 and 3 is congruent to 2, what's the middleman here, guys? 3. If we take 3 out, can we say 1 is congruent to 2? Transitive property of congruence. Guys, our first proof all on our own. Let's go! Okay, questions on this one? Bryson. Bryson, I've already discussed this. I will not ask you to write a proof from scratch. We're all aware of that, right? Yours will be fill in the blank. But was this is kind of helpful that we did one on our own, right? You see that it's not impossible, okay? Peeps, turn these in. All right, that's